So here in doubly linked list also we are going to see about insertion and deletion. So insertion will be having in the beginning, then in the middle you can insert, as well as you can insert at the end. Similarly, deletion also you have all the three possibilities. So if you are aware of your singly linked list, doubly linked list will be added up with only two links. That is not even two links, one link I can tell you. Only the previous link you have to. So when you are inserting in the first position, you will be, you know, that similar line as the linking will be as per your singly linked list, forward link, but backward link alone you have to include it in additional. Similarly, maybe in the middle if you are inserting, there should be two links. That is, when you are inserting in the middle, the previous link of the node which you are inserting, that also has to be taken, and the forward link from the previous node, and four links you have to add it up for your insertion in the middle. Insertion in the end, only two links. Normally end will be null and the previous link you have to add it up. So very few concepts only, apart from your singly linked list, there will be changes over here. So node creation, as I told you, same thing. You are going to create the node using malloc, and here you have to give it as previous as null and next also as null. Then you are taking in the value and you are getting the value and you are assigning the value to the particular node. So insertion in the beginning, what we saw in the last class only, you have to create, then you are assigning the value. If your head node is null, so the meaning is you don't have any nodes in the list. So what is the thing is, if your head node is null, you are going to assign the new node. That is the node which you are inserting is your new node. So a new node will be assigned as the head because that is the only node in the list. Since the list is null list. So the node which you are going to insert is the only node, as well as your node of previous should be null because that is the only node, and head of next, that is head of next. New node you have assigned to head. So you are going to use the variable head only here. So head of previous is null, head of next is null. Similarly, you can also assign the head to the last node because that is the single node. Just in case, sometimes using this last pointer you can traverse. This last pointer will help us to find out which is the last node and everything in certain cases. So else, you have already some few one, if there is no node, this will take place. In case you have already few nodes are there, that is 2 or 3 nodes are there, but you have to insert as the new node. Then what happens is you are going to assign another temporary variable, temp. So you are going to assign the new node to temp, and you know that this is the insert at the beginning, right? So when you are inserting at the beginning, your previous will be always null because there is no node before the node which you are going to insert. It is a beginning node. So your temp of previous will be null, and your initially now, which is your head node is assumed as the first node. So now when you insert a new node in the beginning, still it is not changed. Still your in this diagram you can see, still A is your head node now. After that only you are going to insert E in the beginning of that is before A. So until then your head node is A only. So when you insert this only I have assumed as new node as temp. So now this name is called as temp. So this is the new node which I am going to insert. So how many links I have to make to see here? This link I need, then this link I have to make, this link, then again this link. Okay. So this is my temp node, means temp of previous is null. So this order can be anything as I told you before. Temp of previous is null. Then temp of next will be, initially the node name is head actually. So temp of next is head. So you can see here temp of next is head. Similarly, then from here also you have to take this link. That is, this link has to also come. There is a reverse link from A also. So this also should be done. So this is already named as head, right? So head of previous, that is head of previous. So head of previous is, this is temp. So when you are going to assign some links between two nodes, you need a variable, pointer variable to access this node as well as a pointer variable to access this node. As of now, this node pointer variable is called as head, and this node pointer variable is called as temp. So easily we can tell that temp of previous is null, temp of next is head, then head of previous should be temp. So that are the three lines which are assumed here. And one more line in turn you have to make it. This cannot be head. Once all the links have been done, this should be made as the head node now, because it is the beginning node. So you assign the temp, this node to head. This is the head. Understood? So this is what insert at the beginning. Now when you want to insert this, I took in the last class itself. So, but once again I have told you. Now insert at the end. So normally when you insert at the end, what is the procedure to be followed? Shagun is there? Shagun. Where is Shagun? Okay, fine. Anurag Sharma?
Yes, ma'am.
Yes, for insert at the end, what is the procedure to be followed? That is, which condition has to be checked? That alone you tell me. For singly linked list, the condition, what condition is being...
For singly or doubly, ma'am?
No,
I suppose it's same.
No, I'm asking. See, in single also the same thing, in double also the
Yes,
same
ma'am.
thing. For end condition, what will you follow? What is the condition to be checked? Or to find the last node, you can tell me. Both in single and double, same only. What condition is used for checking the last node?
Ma'am, last node must be null.
Null, okay. Okay, so the condition is when here only in circular linked list you don't have null, because the last node will be pointing to the head node or the first node. So here the singly linked list and doubly linked list, the last node is will be having the next pointer as null. So that is the main condition. So we have to find out where the null is there. That is that the next pointer is pointing to null. There you have to insert it after that particular node. So here also you will be having, you have to create all the necessary pointers, declare all the necessary pointers, then memory allocate the particular new node, then assign the data, that is the value to the particular new node's data. And every time I told you there is an initial checking condition always. You have to check whether your list is full or whether your list is having, not full even, whether the list is having elements or not. If the list is not having any elements, the same procedure as this condition will follow. That means your head node is null. So this will be added up in the beginning itself as your previous line, previous code itself. Else part only, you are going to now move out. That is, you know that else because here you have assigned the head as the last node also. So now your head will be holding the last variable. That is, head is now similar as you give it for temp and everything. Your head is now replaced with the name called last. So what is happening is now you're going to move this pointer, or you can use temp even. That is, but when you use it as a last node, we know that we are going to find the next nodes. So variable can be anything. So now the head is assigned as last, and what we are doing is now we are going to move the last pointer from the first node to find out whether the next node is null or not. So look into this diagram. Assume that this is your last node. Assume head is, this is assigned as last. Now it will check last of next is null or not. No, it is not null. It is having a value. See here, last of next. If it is not equal to null, your last will move to the last of next. So this is not null. So last will move to last of next. So B will now hold the variable last. Now this next is also not null. So last will move over here. Now C's next is also not null. So last will move over D. D's next is now it is null. Actually it was null. This is the one which we are inserting. Now this is null actually. So that means until it is not equal to null means keep on moving the last pointer from A to B, B to C, C to D. Now D is holding the last variable. Now it will tell that your last of next is null. So now our link is very easy. These two links you have to add, this link and this link. So what will be the added link will be last of next will be your new node. Maybe this is your new node which you are being inserting. Last of next is new node. Then this link also you can keep. New nodes previous is already this was termed as last. So here last of next is new node. New nodes previous is last. Similarly, this also you have to give. New nodes next should be null. So this link, that is this forward link, backward link, and this forward link. So 3 links you have to add it when you are inserting at the end. Similarly, when you are inserting the beginning also 3 links has to be added up. So are you clear with this? Do you have any doubt in this line? Are you clear with this? Students, you have to give
Yes, ma'am.
response.
Yes,
Okay.
ma'am.
Okay. So this is what when you insert at the last. Now insertion in the middle. So insertion in the middle, you please recall your singly linked list, how we inserted. We were keeping on, how we did was, I'll show you this diagram. Now this I will be assigning with the current pointer. Now when I'll be checking whether this is the location, if that is not the location to be inserted, what I will do is I will move the current pointer to B. Before I'm moving, what I will do is I will assign this A to the previous pointer and I will move the current pointer to my next node. Now I will check whether this is the location. No means again I will move the current pointer to this location and this will become my previous pointer. So this will be my previous pointer, this will be my current pointer. When this pointer moves over here, this C will take the previous pointer and D will take the current pointer. Likewise, until the position is reached, your pointer will be keeping on moving from one to the other. So when it starts moving to the next pointer, the previous name will change. It will go as previous pointer and current pointer will be moving. So when it finds a location over here, maybe I want to insert in the third location. Now this name, C's name will be your current pointer and B's name will be your previous pointer. Okay, so this is previous pointer, this is current pointer. When this happens, what will be happening over here is I have to give this link, then again this link, this link. 4 links I have to give. These 2 links will be replaced with 4 new links over here. So how about the 4 new links will be? We know the name of B, we know the name of C also. So this is called as previous pointer and this is called as your next pointer. So what I'm going to do is, now I'll do previous pointer of next is my new node. Similarly, new node's previous is my previous pointer. And again, come for this line. New node's next will be my current pointer and current pointer's previous will be my new node. Clear? So that is what given over here. So now see here, these are already known things. If you are assigning the head to the current pointer and if it is null, again the same condition as your previous program. Else, it will be going with the location. I told you your current pointer will be replaced until it finds the location. Your current pointer will be replaced with the previous pointer and your current pointer will be keeping on moving to the next position. Once the location is found, I told you this B is called as B will be called as the new previous pointer, C is called as the current pointer, E is called as the next new node. So when I tell in terms of B, C and E, I will tell that B's next is E, B's next is E, E's, that is what this line next, E's previous is B, that is what this line, and E's next is C and C's previous is E. But you cannot write in terms of data, right? You cannot write in terms of valid. You have to write in terms of the variable of the particular node created for the particular node. So that's what I have told you. This is called as your previous pointer. One is called as your new node. One is called as your current pointer. So previous pointers next will be the new node. New node's previous will be previous pointer. Similarly, new node's next will be current pointer. Current pointer's previous will be new node. Understood this one? So this is the part 1, 2, 3, 4 lines you have inserted. Okay, and to find out the last node, you can move on till to hold the last value. You can keep on moving until to find out which is the last node. So that is the additional line which is defined over here. You can move on finding out where is the last node. Clear with this insertion in the middle? Do you have any doubts? Any doubts in insertion in the middle?
So, ma'am.
Okay, I'll go to deletion now. See, finally, I'll be asking questions to the one who is not at all responding. So here, assume that deletion at the beginning, right? So 2, I'm going to delete it. When I'm going to delete 2, what will happen is initially this was your head node or your starting node. You can keep any name, head node or start node or whatever. So what will happen is when you're going to delete this node, your head node is going to get deleted or your starting node is going to get deleted. So assign the head node or start node to the temp. Okay, when you assign it, what you have to do is first, before deleting this particular node, assign the head variable or the start variable to its next variable. Okay, so first you are assigning this as the start node, means now you assign this to this 45, that is 2 to 45, that is this is called as your start node or head node. So this you will be assigning it to do. So that line is only here. Start should be start of next, or head is equal to head of next. So this will hold the head value now. And now after that, this previous, actually here there is a link for this 45 previous, there is a link to 2. 2's address will be stored over here actually. But now we are going to delete 2, means there is no need of this address at all. So what you have to do is this 45's previous or this head's previous should have null. So our starting node's previous should be null. So start here, the start is head node only. So head should be head's previous is null. And once you assign all this, now you can free this temp. Clear now? So you assign the head to the temp node and move the head is equal to head of next. So 45 will hold the value of head node now. And now you can do that. Your head of previous should be null also. After that, you can free the temp. This is what deletion at the beginning. Okay. Now deletion at the end. So is Shatvik there? Shatvik. Shatvik. Shatvik is not there. Manoj. Manoj.
Yes, ma'am.
Manoj, are you listening?
Yes, ma'am.
Okay, when you delete at the end, when you delete at the end, what is the procedure you follow in singly linked list? When you delete at the end,
The last should be equal to temp.
last, don't read out this, just I'm asking, don't see the screen and see. Now you will confuse. You just tell me when you delete at the last, actually what you will do.
The next to the
That is,
last should be null.
last of, that is when you delete the node at the last node should point last next. Otherwise the node which you are deleting, that will be deleted, means the previous node of the node which is being deleted should be null. Okay, so that is okay, so that is what you have to follow here also. See here, according to this pseudocode, your temp is there and you are assigning the last node. So initially when you create itself, you will be having a pointer variable. So you can unmute your mic. You can not mute your mic, mute. So the last will be pointed to the temp. So now it is being checked whether the temp of previous is null. Why this condition is being checked is, suppose that is the only node. That is when you are going to delete, that is the only node which is the first node as well as the last node. If both are same, so what happens, you are going to delete that particular node. So your head and the last node will become null. So that is what it is taking. Only the first node's previous will be null. So when your last node is assumed as temp, it will be starting from the first temp of previous is equal to null. That means that is the only node available in the list, means your head and the last, whatever it is, will become null. Okay, so that is this condition. Else what happens is, let's see here, your last node will be moving on, the pointer will move on till the last node, and what happens is, if your last of next is null, that is the node which you are going to delete. So now what will happen is, you will be moving the temp, right? The temp will be keeping on moving, right? So what will happen is, your last node will become the temp of the previous. That is, your final node, the last node is now pointed as temp now. So that is going to be getting deleted. So before you delete, you have to make the previous node of the node which you are going to delete as the last node. So last will become the temp of previous. And once you define the last node, so for example, I'll take this diagram itself. So when you want to delete this one, okay, one is the node which you are going to delete because its node is last. Now this is only holding the value temp. So now this should become your last node. 3 should become your last node. So what you are doing is, your last is equal to this previous. Temp of previous will be your last node. So now this 3 will hold the last node, and now this one's next. 3's next should be null. So last next should be null. Then after that you can delete this node. So this is what your deletion at the end of your doubly linked list. Now when you come for the, so same thing there. Now when you come for the middle, for middle alone, you have to follow middle also the same procedure as you do it in the, what is that, your singly linked list. What in singly linked list, what you will do, you will be starting from the first node. See, when we are middle in the sense, it can be I can give my first node to be deleted, or my second node, or my third node. Any node I can delete in the middle. So that is what deletion in the middle. Any location if I give also, it should be deleted. So first the checking condition is, while temp not equal to null. That is, temp is assigned to head node now. Are you listening, students?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, okay. So, but after once after recording, I could see the same persons only. I could see they are responding, and the other guys are very silent. I do not know whether you are listening or just. So that's what I planned of asking questions in the middle. So be alert. Whenever I ask few questions, try to answer it. Okay. So so listen carefully. So when temp, so you're assigning the head to the temp now. So when you're assigning the head to the temp, so first you're going to move this temp from the first node till the last to find out which node is to be deleted. So while temp not equal to null, temp not equal to null means your list is not empty. First you are finding out that, checking out that. So if this is true, it will come to this this line. If temp of data is equal to value, that means it will first check. 1 minute. I will open another one also here for you. Can you see the screen, both the screens?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So see here, when your temp of data equal to value. So that means first when you are going to find out whether 45 is the particular value to be deleted. If that is the first value to be deleted, then if this is true, what happens is, if that means temp of data equal to value means my first node is going to get deleted. In this case, I'm telling, if I'm going to delete 45, So if this is true, it will come to this line and it will check. So that is the first node. When the first condition itself is getting satisfied, that
Ma'am,
is your, yeah, tell me.
ma'am, over here, how do we know if it is checking data value for the 45 node or the
No, no,
one?
no, no. Head is the first temp. See here, head is equal to temp.
Okay.
Okay, so anyway, whatever you're going to delete, it will start the checking as you do it in searching, right? You start from the first element to search and you will be comparing. Same thing. You will start from this node only because head is assigned to temp. So this is your temp node now. Forget about what I have written over here. Assume that first this is your temp node. So wait a minute. I'll use something. So initially this will be your temp T node, TMP. Okay. So this is your temp node. So when I'm finding it out when this 45 is the temp node to be deleted, then defaultly it will check the next condition. Its previous is null or not. If it is the first node, then that node is to be deleted, means this condition will be followed. Your head will become it is only one node, means this case. In case this is not, that means my 45 is not the node to be deleted. So what it will do, it will move to 3. So when I'm moving to 3, that is when this condition is false, my temp of data is not the particular value. When this condition is false, it will come over here. This else part will take into count. Okay, when my temp of data is not the value to be deleted, that means my 45 is not the value to be deleted. So what it will happen, it will come to the else part. Else part means the temp, the name temp, this temp will be assigned to the variable var. Okay, var is the variable which now I am assigning. Now remind of your the middle node, not middle node, insertion when we made, when I am moving the cursor from your current pointer to the next pointer, what I will do is I will assign the current pointer to the previous pointer and then only I will move the current pointer to the next. Similarly, when 45 is not the node to be deleted, what I will do is I will assign this temp to var. That is what given here. Temp is assigned to var and temp will move to the next one, temp of next. Okay, and temp 1 will be temp 1's next. Okay, so listen very carefully. When this is not the node to be deleted, I will go to var. When this is not the node to be deleted, I will assign this as var. My temp will move to next one. My temp 1 will move to the next one. Temp of. Now again, it is coming to 3 now. The checking condition is coming to 3 now. Suppose this is also not the value to be deleted. Now 3 will become the var. Temp will move to the next one. Temp 1 will move to the next one. Okay. So likewise, when till it reaches the particular value, my 3 pointer variables will be keeping on moving. Temp is assigned to var. Temp will move temp of next. Temp of 1 will be the next one. So it moves like this. These names are needed since we need to join it. That I'll tell you now. So in this case, 45 is not the node to be deleted. Now here, according to this diagram, 3 is the node to be deleted now. So what happens when it comes and check temp of data is equal to value? True. 3 is the node to be deleted. Now it will check whether temp of previous is null. No. My 3's previous is not null. So it won't go into this part also. So it will come to this part, else part. Else part, how it will make is, now you are going to delete this temp, right? So what you have to do, this link has to be deleted and this link also has to be deleted. So my link should be now from this to this, then this to this, right? So how I can give is my var of next, that is this one's next should be temp 1. Clear now? My var's next, because this I'm going to delete now. My var's next
Yes, ma'am.
should be
But
temp
then
1.
only after the temp, the middle one is deleted, right?
Yes. Before deleting itself, you have to give the value. My var's next should be temp 1 and temp 1's previous should be var. Clear now? var's next should be temp 1. Temp 1's next, temp 1's previous should be this. Then after that, you free this temp. Clear now? Once again, I'll tell you. Listen very carefully. Now, head will be assigned to initially temp, and it will check whether that is the node to be deleted. When this is not the node to be when this is the node to be deleted, then it will check it out whether the previous is null or not. When if this is not the node to be deleted, it will assign the same name, that is temp name, it will assign to another variable called as var, and this temp will become temp of next, and temp1 will become also temp of next. So what happens is this will become temp and this will become temp1. Now this is your next value, holding the value 3 now. Now again it will check temp of data equal to equal. That is 3 is the one which I am going to delete. If not, again this will become var, this will become temp, and if there are any other values over here, then that will become temp1. So likewise it keeps on moving.
So ma'am,
Yes,
what will
tell me.
happen to VAR?
What ma?
The first one. What will happen to the name of the first node?
First node will become var. Temp you are assigning as var. See, listen here.
But ma'am, you said that the second node will become VAR then.
No. And always the second node, wait a minute. Okay. Now listen here. See here. When I'm going to first temp of data is equal to value, right? So it is going to check whether 45, assume that I'm going to delete only node 3. Okay. Node 3 is the node to be deleted. So now it will come. My head I have assigned to temp now. My temp is over here now. Temp variable will be initially here only.
Yes.
Okay. Now it will check whether 45 is the node to be deleted. No. Then it is no. See here, in this code you are able to see the code, right? It is not the node to be deleted. So what happens is it will come to the else part. This also will not be satisfied. Come to the else part, and what it will happen is this name was initially temp, right? 45 was node name was temp. That I am assigning to var, variable, var, something, one name you are assigning. Then what I will do is I will move my temp to the next one, temp of next. Okay, so my 3 is holding the value temp now. And another one variable also I am moving. Temp1 is equal to temps of next. So this will be taken as temp1. So now I have 3. My var is one variable pointing over here. Temp is another variable pointing over here. Temp1 is another variable which is pointing over here. Okay. Now again, which is holding the value temp now? 3 is holding the value temp now. Okay. So when 3 is holding the value temp, what I will do is now it is asking whether temp of data is the node to be deleted. Yes, true. So now what happens? When it becomes true, my next line will execute. Temp of previous is null or not. This one's previous is null? No, because it has already have a value over here. So previous is not null. So this one's else part will execute. What is the else part is this connection will be cutting off, and this connection is going to cut off now because I'm going to delete this 3. So now I have a name var over here. I have a temp1 over here. What will happen is var's next will be temp1 and temp1's previous will be var. Okay. And after that, I will free this temp. Clear now? Now you look into this line. Now you look into this line. Okay. So now you see here. You can see over here. This condition is checked. Now it is whether if this is true only it will come here. Otherwise, if this data is not to be deleted, it will come to this else part. It will assign to temp and 2 variables. It will keep on moving. Why we need the 2 variables is to link it. Okay, when it is just found the node, we have to link this node and this node, right? See here, that is what shown over here also. So when this is true, it has to check this condition. When this is true, this will be satisfied, else this part. So in this case, your temp of data is 3, but your temp of previous is not null. So it will take the condition and the else part. That is your 45's next will be 1 and 1's previous is 45. But you cannot write it with the value, right? with the name of the variable only you have to write with the pointer variable. So this name was var, this was temp, this was temp1. Suppose, see, listen, you have one more node over here. In that case, 3 will be shifted over, var will be shifted to the next one. This will hold var, this will hold temp, and next will be temp1. Some other, if there are any other value. Likewise, your variable keeps on moving from, pointer variable keeps on moving from one to the other to check whether that is the node to be deleted or not. Okay, so just go through it once, and if you have any doubt, you can ask it later even.
Ma'am,
Yeah, tell me.
ma'am, deletion friend, can you just open the slide again and just give a brief once again?
Which one? Deletion, all deletion?
From the end.
From the end. Beginning, you are clear, right?
Yes, ma'am, beginning is clear. The end
Yes.
one.
Okay. End one, what you have to do is you have to assign the, because your first node will be holding the head position as well as the last position when you create. So when you want it for, you can keep it as, or else when you see, this is only half of the snippet, right? So I have taken directly last as temp, but when you write the snippet as a whole, you will be giving head as the first node, and the last you have to keep it on checking whether it is moving. Last node has to move till the till whenever your insertion happens. When you go to the insertion in the beginning, you could see that you will be moving the last till the node which is being created. So this is, since it is half of the snippet, I have taken the last node directly to temp, that's all. So because last, there will be a pointer called last also, in doubly we will be using it. So last node is pointing to temp. So when it is pointing to temp, first you are checking whether its previous is null or not. Why we are checking its previous is null? If that is the only node, means its previous will be null. Okay, so if that is the only node, then that is the only node, head node, and that is the only last node, means previous also will be null and the next also will be null. So if you are going to delete that particular node, everything will become null now. Head also null, last also null. There is no other node in the list. That is the condition for this checking. But in case if your last node is not null, maybe you have multiple elements over here. Okay, so you want to delete one. When you want to delete one, what happens? Your 3 should become the last node now. That is your null node now. 3 is next. Should become the null node. So this line is very important. Last is equal to, your temp will be keeping on moving, right? So last is equal to temp of previous. That means your temp is now here. 1 is holding the value of temp now. Now last will be your temp of previous. This is holding the variable now last node. Okay. 3 is holding the variable now last node. Then again you have to give another line. My last next should be null. Last next is null. And after that you free this 1. That is free this temp.
So ma'am, in that moment, last will be 3.
Yeah, last will be 3. 1 will go off. Understood? Okay.
Yes.
Now when you come for the middle value, middle deletion, first you have to check, first you assign the head to the temp, that is your first node is now assigned as the temp, and your temp not equal to null. That means you have multiple elements in the list. Okay, and now you are checking out whether that is the node to be, that is the first node is the node to be deleted. If it is not true, what happens? It will come to this part, else part. So your first node is not the node to be deleted. So you have to now give another variable for the temp, because temp keeps on moving to find out whether that is the node to be deleted. So now temp you are assigned to var, that is, see here, your 45 is assigned to var now, and temp is equal to temp of next. That means now this was temp, right? 3 is taken as the temp now, and temp 1 is equal to temp of next. So now 1 is taking the temp 1. So this var will take the temp is taken as var, and temp will be temp of next, this one. Now again temp 1 will be this temp of next. So this will become, so the order should be like this only here. Suddenly it will come correctly. So var temp 1, this is the value. Now 3, it will check whether 3 is the node to be deleted. Suppose if 3 is also not to be the node to be deleted, means again this line only will be followed. This will be taken the value var, and this will take temp, and next one will go as temp1. Okay, likewise it goes on changing the node pointer variable from the one to the other until it finds the value. Once it finds the value, now next condition is it will check that whether its previous is null. Previous will be null only if it is the first node. In our case, we have already 45 here. So this is false now. This is false now. When this becomes false, automatically you can draw the connections now. Connections will be, this one's next will be temp1. I think this is temp1 now. VAR temp1. So 45's next will be temp1, and temp1's previous should be this 45. That means, in other word, I can tell you 45's next is 1, 1's previous is 45. According to the name, when I tell, I'll tell us VAR's next is temp1, temp1's previous is VAR. And then you can, this name is called as temp, you can free the temp. This is what, free the temp. Clear now? Clear?
Yes, ma'am.
Just go through it once again, you will find it easily. What's the time? Okay, fine, ma'am, I'll take it.
Ma'am, have you uploaded this PDF in GCR?
What, ma?
Ma'am, have you uploaded this PDF in GCR?
Today I will, after the class I will upload. Okay. After the class, the
Okay,
video I'll upload. Now I'll tell you this also. This is also actually searching. Just I will go through it. You refer this also. If you want to search an element, if you want to search 1 or 2 or 3 or 4, whatever it is, how you have to find this? We are initially declaring the variable as start, temp as start. There is the start or head. Here I have given, here it is given as start, but the meaning is head only. Temp, and initially the count and flag. Flag is just to find a checking condition whether to find. So here the algorithm is given. You can also go through the algorithm. First you are initializing the temp as the head. You are iterating the loop to find the address and whether the element is present or not. If it is present, you raise the flag as 1, increment the count and break the loop. At last, if it is found, you can tell it is found. Otherwise, you can split it off. If the location not found. So here the same thing. If temp is null means no elements in the list. So return -1, no other value. Otherwise, if temp of next not equal to start, this is circular linked list. See here, the searching is found in doubly circular linked list only. Okay. So here you can see here single circular linked list. Single circular linked list, I think. So the name should be changed to single circular linked list cases. So what is happening is, while temp of next not equal to start, that means it is not the end. If temp of next is equal to start means it has ended. Your loop, your list has ended. So you can keep on incrementing the count. You are going to check the next element. So if temp of data is equal to search, if that is the data, you can increment the flag and move to the next temp. If, for example, if your temp of next is equal to start, if this condition is failing, not equal to start, this will process. If this is equal to start means that is the last node. Assuming if this temp of next is equal to, maybe this is only one element in the list and its next is to the start means this is the first node and this is the last node. But we have multiple elements. So when you are having multiple elements, you can keep on incrementing the count and you can search whether 2 is the element to be found or 3 is the element to be found or 4 is the element to be found, etc. But in case only one element is there, is equal to start means then this condition will take place. That is, if that is the data to be searched, only one element and that is the data to be searched, then you can increment the flag.